My name is Cole. I have just returned from Japan, Tokyo, at the Shibaura Institute of Technology, or SIT University. I was working in the Department of Electrical Engineering in the robotics lab under Professor Ando and student tutor Mr. Tomaki. So over the course of the last 2 weeks, I have been working on an autonomous vehicle prototype to help ease the flow of traffic in Japan and ease congestion. Just a bit of background information on my project before I get into it. Japan has an ever-increasing stress on effective, punctual and affordable public transportation, and even more stress on those tasked with satisfying these demands. The sheer amount of daily commuters in Japan on Tokyo's rails and on their streets is more than enough to often cause delays. We've all heard of the phrase, time is money. In the case of Japan, even a small delay can end up having serious repercussions. One major contributing factor of this issue is urbanization. Now, to give you an idea, Tokyo has the highest urban population density of any city in the world, with its population during the daytime being 6 times that of its registered residencies. So it's easy to understand how easily public transportation can become overcrowded. Now, the solution would be to find a new form of public transport to help ease the congestion and smooth out the flow of commuters in and around Tokyo. So my design was an autonomous electric vehicle that uses image sensors to detect road signals whilst following a set route. Although it may be more expensive to manufacture than a normal vehicle or a taxi, I believe that in the long run it should work out to be more cost effective, as no wages need to be paid to a hired driver. So a bit of technical background on the components that I used, the various components. So I used a Raspberry Pi 3 Model B, an empty circuit board provided by the university, 2 small 5-volt motors, an image sensor or a camera, a battery pack and a gearbox, or a double gearbox that we built. So to start off my project, I decided to start by building a line following robot. To do this, I started with an empty circuit board and soldered the various components onto it, such as the diodes, resistors, capacitors, transistors, and so on. I then attached 3 LEDs underneath the circuit board and 3 image sensors just behind them. Next, I built my double gearbox, attached the 2 5-volt motors to it and the wheels, alongside with a battery pack, and in turn connected them all to the circuit. I then decided to expand the functionality of my robot by attaching a camera peripheral for image sensing and a Raspberry Pi 3 Model B to program my robot. Now, I mainly used 2 programming languages for my robot. So the first one was Python and the second C, or Robot C. I started off my programming with my line detection code. So it basically works by taking the binary values, so the 1s and 0s, obtained from the light sensor, detected from the reflected light from the LEDs, and adjust the left and right motors accordingly. Once I had done that, I decided to work on my color and image detection program. I wrote this using C, and I first needed to define what colors I wanted to detect. So in this case, I wanted to detect red to symbolize a traffic light. In the case of red has 2 HSV values. Now, an HSV value is, on a basic level, the region in which color is found on the color spectrum. So because red has 2 HSV value regions, it makes it extremely difficult to narrow it down to detecting only the color red and reducing any noise of other colors. Once I had gotten it close enough to the desired red that I wanted, I then simply stated that if red is detected, motor drive equals 0. Once I'd done that, I needed to make my 3 programs communicate: the line detection, the color and image detection, and the GPS. I allowed them to communicate by using locally based client-server architecture, using my server code in Python and self-written client-side code. Again, putting it all together, the final product is what I'll show you in this video. So as you can see, the robot follows the line until it reaches the first taped location, where it stops, waits for a few seconds, and then continues. This would be an input location where the robot would be told to stop. In the next video, I demonstrate the color detection. So as you can see, the robot again follows the line until I display the color red when it stops. Once red is no longer detected, it carries on moving. Okay, just a few of the challenges I faced. Adjusting the light sensors to pick up or to detect when it is no longer on the line or is on the line was extremely difficult. The components were really small and difficult to adjust. I found it extremely difficult to find the correct HSV values for red only. There was plenty of noise that I was picking up. It kept stopping for other colors such as yellow and orange, anything that was close to the HSV region of red. And lastly, in my simple GPS, finding the right amount of time between the destinations was extremely precarious, as if one time parameter was off, it threw them all off. The language barrier was also a prevalent issue. I found it extremely difficult to communicate with my professors, but I managed to get through it and nonetheless enjoyed it. In conclusion, this internship program has provided me with invaluable first-hand experience in the lab using the equipment in the field of electrical engineering and in the field of robotics. I was able to learn from my peers and my tutors and my professors. I was able to interact with students from all around the world, of all different cultures, of all different ethnicities. At SIT, I experienced learning not through taught example, but by being thrown headfirst into the issue on a practical side. And I really enjoyed that. I enjoyed the challenge. I enjoyed having to figure things out for myself. In terms of experiences outside the university, I really enjoyed the various shrines that we went to. It was calming and humbling to experience a different culture and a different religion. I really enjoyed Shibuya crossing, the busiest crossing in the world. It was a fantastic trip and definitely a life changer for me. I hope it'll set me forward in achieving my dreams and my goals.